Hopefully you're here for the Snowflake connector for Kafka. I am Brad Culberson. I am a member of the Snowcat team at Snowflake. I've been at Snowflake for about 4 years. The Snowcat team is a customer acceleration team. Before that, I worked on the field CTO office with Keith.
Cool. Hey, everyone. I'm Keith Caputis. I'm a field CTO with Snowflake. My focus is on data engineering. I do a lot of work with data ingestion, data transformation, and in particular streaming. And I've been at Snowflake for a little bit more than 1 year now.
The agenda for today, we've got quite a few things to cover. So if you have questions, we're going to wait till the end and catch you either in here or outside. But we're going to be really tight on time, so we're going to go extremely fast. You can tell by the size of the agenda. We're going to start with a very quick intro of why to use the connector. We're going to do an amazing demo today if everything works well. We're going to talk about how that is working, how to size your Kafka and Kafka Connect clusters, all the configuration options inside those and how to set those and when to set those. We're going to talk about a few popular streaming patterns using these on Snowflake. Keith's going to go into monitoring and error handling at the end, and I'm going to talk about some new things that Snowflake has coming up soon that you'll want to know about. So first off, I'm going to just walk quickly through why you would be using the connector. Someone here may not have used it yet. But Kafka is a really, really popular streaming platform that companies have adopted in the industry. Oftentimes this is for things like IoT events, click streams, financial market data. We've got a lot of telemetry data that's flowing through these streaming pipelines. You probably have many of these in your offices today. And a lot of these are now flowing through Kafka-compatible systems. Those Kafka-compatible systems, it may not just be Kafka, it could be Red Panda. Today's demo is using Red Panda. It could also be like Microsoft Event Hubs. It could be managed Confluent also. The main reason people are using this is because it's massively scalable. It was originally built by LinkedIn, but it can scale to nearly any volume of data. I've literally never seen it hit a customer's limit. The Kafka connector itself has two separate modes. When we released the first version of the Kafka connector, it had the snowpipe mode. And the snowpipe mode itself was basically batching up data coming through the partitions in Kafka. It was creating a file, it was uploading a file to Snowflake, and then having a serverless warehouse grab that file and import it. That would often take about 30 seconds or more. All the data was brought in through a variant field, so it was all semi-structured whenever it landed. Nothing was schematized at all, but it worked pretty well. It actually could get really high throughputs, so it worked pretty well. Well, we had a lot of customers reaching out saying, hey, the 30 to plus second delay for getting data in Snowflake, plus the mix of not having the data schematized at all was really painful. So there was often transformation pipelines that were running after this. Delays were starting to get to minutes by the time you bolted all the pieces together. So we built a completely new SDK, the streaming SDK itself, and we added that SDK to our Kafka connector. And there's now a streaming mode in the Kafka connector. I highly suggest you check that out. The streaming mode really just cuts down this latency now. So now we're down to data queryable in seconds. It's also, in almost every case, it's cheaper. So if any customer ever reaches out saying, what should I do? Universally, you should start with streaming mode. It's usually better in almost every single case that I've seen. And it's our newest thing that we're adding all the features to. The demo today is 100% using the streaming mode. Keith is going to do the demo.
Cool. All right. It's time for the demo. Let me see if I can change. All right. Change screens here. And I'm going to start by showing that in my ingest schema, I have an empty table called lift tickets. So there's no rows there. So empty table. I'm going to quickly jump over to Red Panda. As Brad mentioned, this is what we're using for Kafka infrastructure today in the demo. It's not specifically Kafka, but it's fully compatible with Kafka, and it's very fast, and it runs well in Kubernetes, which is what we're using as well. And so you can see here, I have an empty Red Panda cluster with 12 brokers. I can show that I have a single topic here with 400 partitions, replication factor 3. And then let me jump over to connectors, and we'll see that I have a Snowflake connector that has been sitting idle. Let me just restart it here to make sure that we're getting a clean start. Give me 1 sec on this. There we go, fully running, 400 tasks. And so this is a pretty aggressive configuration where every partition has a dedicated task. And so this is going to give you maximum possible throughput. And so now that you guys have seen, I have Snowflake Sync here in Red Panda. with 400 tasks. Let me quickly jump over to my terminal. And we can see that this is just a tool that kind of lets me manipulate Kubernetes resources here on the fly, but you can see all my Red Panda pods. Let me quickly jump over to, sorry. There we go. I'm going to turn on, so the data source here is just going to be a custom data generator application that runs in Java. It will run in containers. And I'm going to quickly scale it up to 20 pods. So let's get that going. And so this is going to see all the containers starting. And so the data generator here should be running. So let me jump back to Snowflake. And let's see if we have data coming in yet. So you can see here some example records. This is just, as I mentioned, a synthetic data source. And let's see kind of where we're at now with account. Okay, so we've got, in just a couple of seconds, we've got like 56 million records. So what I'm going to do is I'm just going to let this thing run while we present, and then we'll come back to it later and see how it's doing.
So now I'm going to go through some architecture here of how this is working. Inside this, we have some producer. So in the demo, we're running just a simulated data set, but some source of data publishes to Kafka. That goes directly to brokers. So those brokers are storing that data in partitions inside of a topic. The data goes from the cluster into the Snowflake Kafka connector, which is running inside of Connect. And in here we have a bunch of nodes running. We call them worker nodes. These are running our SDK to be able to send data to Snowflake. And this is separate from your Kafka cluster. Like we have those running on completely different instances, running on different clusters. And the data is flowing from basically the brokers into our connectors. And then it goes from our connectors into Snowflake. What's happening here, I mentioned earlier, we're using the ingest SDK, which is from Snowflake, that's written in Java. That's open source. You can actually use that for other tools also. But that ingest SDK is taking data coming from the partitions, and then it is batching those together. We create Parquet files inside of this, and then upload those Parquet files into Snowflake's internal table storage. So the client here is batching the data together for us, uploading that directly to table storage. And then after it's in this storage, it then registers that data directly with our metadata. So what's nice about this is this data came into Snowflake, uploading the Parquet, committing to our metadata without even using a warehouse. So no warehouse costs and all that flow. That data is immediately queryable then. That's how we're getting those 1 second delays now, where these things are flowing in extremely fast. So as soon as the data is committed to us, the consumer can start querying it. What the consumers are doing to be able to query that is it's combining what is in FDN, which is our format for storing columnar data. It's combining that with all the data that's currently in flight with the BDEC Parquet files. We call them BDEC, but they're Parquet files. So we combine all of these for query. Long term, we don't want to keep a bunch of small Parquet files in another format in our infrastructure. So we eventually run a async service that we call file migration, and that moves those in the background from Parquet to FDN. But the data is available that whole time. So data availability is really fast. In the background, we'll shuttle those over to FDN. So long term, you get the performance of our compressed columnar formats, and you also get that data available really quickly. On this diagram also, we'll talk about this a little bit later, but I just wanted to call out, you can see here at the top how it's combining multiple partitions to one Parquet file and one BDEC. This is because client optimization was on. So that's something that's optional inside of the configuration. We can do that, but you can also disable it, where literally it's a mapping of, you can control this behavior where one partition goes to one buffer, which writes to one Parquet file. That could be useful for optimizations. I think our demo is running in that mode, isn't it?
Yeah, it's running in the bottom mode. We have client optimization turned off, which I'll talk a little bit more about that when we get into configuration. But really in really high throughput scenarios is when you would want to consider turning that off.
Yep. So we want to talk a little bit about sizing. Often when me or Keith get pulled into a customer conversation, it's slow, and we're trying to figure out what's slow, right? So this is a good way to start thinking about these systems and how they're working. In this list, this is kind of a checklist of what you should be thinking about. Network bandwidth. To get the demo working today, we had to choose instances that had plenty of network bandwidth. We had to do dedicated IOPS on these nodes to make sure we had enough IOPS on the brokers to make sure it could keep up with this. We chose replication factor of 3 today. There is a consequence to increasing replication factor because of the amount of IOPS that are happening. As the replication factor goes up, you're now replicating all of this data across all the brokers. So now you're getting multiple writes. Like there's a multiplication factor there of all of the writes happening. So with a replication factor of 3, every single message that gets written 3 times into your brokers. So think of that multiplication effect if you increase that number. Disk size also, you do have to have enough disk and also 3 copies of the data there. So think of needing more than just the data that's flowing. You need your multiplication and replication factor in there too. For choosing the number of partitions, I'd like to jump down to the bottom because this is the most important thing. I always try to target basically 1 megabyte per second compressed per Kafka partition. So if you know you're going to try to get 400 megabytes a second, it's probably 400 partitions. Today we're running 400 partitions in our demo. We're getting a bit higher than this, but it's because of the data that we have. But this is a very good starting point. Definitely should not have like one topic and one partition and try to shove through a lot of data because it's not going to be successful. And what this does allow you to do in Snowflake, by having multiple partitions, that means multiple instances of the connector can all be running in parallel. So this is how Kafka's parallelizing work. If you don't have enough partitions, you just can't run enough connectors to get enough throughput into Snowflake. So this is really important. You can choose too big of a number. So you also don't want to just say, oh, 1 million sounds good, let's just do that. Because that also adds a burden to the system where now you have 1 million partitions that have to do leader election and has to do more work. So your Kafka cluster will be under more work. And we also then will end up needing something like client optimization to try to combine that to try to fix the inefficiency of having really tiny partitions. So you definitely want to try to target around 1 megabytes per second per partition. Whenever customers are choosing like message formats, most orgs just pick one. So you could be doing Avro already, you could do JSON. If your org does have this mix, so if different teams can pick different message formats, you will have to run a different connector for those different teams because you can only pick one format for everybody. But most orgs standardize on one. I'd suggest you standardize on Avro or JSON and then do that for everything. Task count, for us, Keith mentioned we are currently today running 1 task per Kafka partition. That's a best practice. We see the biggest performance from doing so, and this basically allows us to be able to have this throughput that's the highest we can get. The single task processing many topics and partitions, while that's possible, you're not going to get the most throughput for that. So we do see customers saying, I don't want that much infrastructure, so let me combine a bunch of topics onto one Connect node. That will work. You will just not get a lot of throughput for it. So if you're judging this for performance and you're planning to push a lot of data through it, don't try to combine, don't use the client optimization where we're combining partitions together, and don't have one consumer consuming from bunches of topics. Again, it's the same number. Try to target 1 megabyte per second compressed per task. And that should all work if you've chosen everything so far. For the connectors themselves, we like to see 2 CPUs per task, and then 2 to 4 gigs of RAM. That's enough for the JVM to work pretty effectively. Today we're running 100 Connect clients. So we've got 12 brokers and 100 Connect clients, or Connect nodes. On the instance types, we are seeing a lot more success with Graviton. We're in Amazon today, so we are using Graviton. You will want to play with this a little bit because you will see performance and cost savings by using different instance families there. The biggest deal with that's looking to make sure that you have enough network bandwidth on the instance family you're using. And in our experience so far, the connectors are always working better in Amazon, at least with Graviton. So try to provision as much as possible. And also, I would say if you're starting a project, over-provision a little bit and then put in some telemetry and watch it. In many cases, I talked to a customer and they've tried Tiny for this, and it's like the whole thing's a disaster because it's basically just not working at all. It's like, get it working and then tune after it's working instead of just fighting against some instance that has no CPU and no memory. Keith is going to go through configuration of the connector now.
Cool. Yeah, thanks, Brad. Let's get started. All right, so first of all, I'm going to talk about configuration in Snowpipe mode, which, as Brad mentioned, is how the first versions of the Kafka connector, this is how they worked. And in this case, there's really 3 settings to think about. And it controls the buffer in the Kafka connector itself. They control when it flushes. And so in this case, because in Snowpipe mode, you're performing file-based ingestion, you do want to think about file size. So like typically you're holding data longer, increasing time in the buffer, trying to get to well-sized files. In this example, it's 100 megs uncompressed. Let's say maybe that compresses down to like 10 megabyte files. That'll be a reasonably efficient amount of data to load. Now, that being said, you also see flush time set to 600 seconds, so that might wait up to 10 minutes to get that much data. So as you can see, this is not the best for low latency use cases, and this is really where you'd want to look at switching to streaming mode. Now, if you notice here on the top of this slide, the main thing you have to change to switch from Snowpipe mode to Snowpipe streaming mode is just the ingestion method setting. And in this case, it is a little bit more complex in terms of how the buffers work and how it flushes. So there is the same buffer that existed before, but there's also an additional buffer which was in the diagram that Brad showed. And so this is the case where here we're optimizing for low latency. We have the Kafka buffer flushing every 1 second. You'll see buffer size bytes set to 16 megs. That's the sort of maximum recommended size for a single flush from the Kafka buffer into the SDK. And then I have a high count of records because really I want this to be flushing based on time. This is something where there's 3 separate things. It's good to really flush on 1 or 2 of them rather than to flush on all 3 of them because it's more understandable in this case. It's just going to flush every second, basically. But now there is one more setting to look at, which is it's been in the Java SDK for a while. It was exposed in the Kafka connector as a version 2.2. It's called streaming max client lag. And so what this does is this actually controls the buffer which directly writes those row sets to Snowflake. And so here it's set to 5 seconds. And so the behavior that you're going to see is the Kafka buffer is going to flush every 1 second. It's going to flush 5 times. And then after 5 seconds, the cumulative data is going to get uploaded and committed to Snowflake. That is, unless there's so much data that the SDK buffer flushes based on size. So it can flush based on 1 of 2 dimensions, either time or size. It's very similar to how the Kafka buffer works as well. And one thing to note here is the default value for this is 1 second. So if you don't change it, you have your buffer flush time set to 1 second, your max client lag set to 1 second. You'll probably see data within Snowflake in like 2 to 3 seconds. So that would be like the fastest.
With that being too small, you may have some consequences there of just having really small Parquet files or BDEX inside of Snowflake. So when we're tuning this, we often will increase this number to just get to a little bit better sized files in there.
Yep, and we'll talk a little bit more about the different patterns and maybe when you'd want to hold data a little bit longer versus when you don't need to do that. So then one other thing, so this has come up already a couple times. This is the setting for the single client optimization. And really what this does is within a single JVM, this determines how many instances of the SDK there are. So if you have a Kafka Connect worker with multiple tasks running on it, when client optimization is turned on, all the rows that are inserted are combined together and then uploaded into the table as one chunk. When you turn it off, that it does not happen. And so it is on by default. It's typically a good thing to keep on, but you might want to turn it off in the case of high throughput. The other scenario where you might want to turn it off is if you're very carefully controlling what data is written to Snowflake in which chunks, which we'll talk a little bit more about that. Turning off client optimization can ensure that a single partition's data is written to a single file, which can come into play for query pruning.
Having that on really helps us a lot if you're not hitting, like if you have some partitions or topics that don't have enough data flowing through them, so it's not getting that 1 megabyte per second, it helps us batch multiple partitions all together when we're writing the Parquet files.
Yeah, and it can also decrease latency. So I would keep it on as a default, but maybe as you start to increase scale, test what happens when you turn it off and kind of see if it's worth keeping on or turning off. I want to talk a little bit more about message format specifically. So Kafka Connect works using the concept of value converters. If you've used the Kafka connector previously in Snowpipe mode, you would have used com.snowflake value converters like the JSON converter or the Avro converter. With the switch to Snowpipe streaming, we've actually moved towards using community value converters. And so you would be using the org.apache ones. And Brad kind of mentioned, messages that are in Kafka can have schemas or they cannot have schemas. Typically when you're getting started, using schemaless JSON, can be the easiest. Avro with the schema registry can be faster. So there are trade-offs there. Let's move on. So this is an important setting, schematization, and this is a feature specifically of using the Kafka connector with Snowpipe streaming. And what this does is rather than loading all the data into a single variant column, actually creates the table with all the top-level attributes of your messages. It either infers the schema or it uses the schema from your schema registry. And this can actually add columns as they show up in your messages, so it's performing ongoing schema evolution as well. And so this is great. This is really good for improving the usability of your raw data. It's also good on optimizing query performance if you're querying data directly, because Snowflake prunes best on top-level columns of the streaming data. But there are cases where you may not want to use it. And so like one example would be, let's say you have a topic with multiple message types. For some reason, 2 different message types have the same column, but they have different data types. Like obviously, if you have an integer column, you can't insert a string into it, and that could trigger an error. I'll talk a little bit more about how error handling works later. But then the other scenario where you might want to turn off schematization or at least think more about what you're schematizing is if you have either very, very, very wide messages, or you have topics that have multiple event types, and the superset of all the attributes gives you like thousands and thousands of columns. Like that can create wide, sparsely populated tables in Snowflake, which could impact query performance and also might change what your clients are used to getting back. Like if you're coming from a different system and you're used to getting like just the columns that are pertinent to a specific message type, and now you get thousands and thousands of like no columns, that can add more load onto your clients as well that are querying data. So the other thing I wanted to call out specifically is the use of simple message transforms. And so these are a really powerful tool. I like to think of them as kind of being a Swiss Army knife where you can put lightweight transformations directly into the Kafka connector. You could do stuff like redacting or removing specific fields that for whatever reason you don't want to load into Snowflake. You can reshape records. So if you are going to, let's say the example that I said where you have a topic with multiple event types, you might want to pull some of the common attributes up in a transformation here, and then keep all of the message type specific attributes in a variant. This is a pretty easy way to implement that. It's just a little bit of Java code to like reshape messages on the fly. And then you can do stuff like adding additional metadata or headers if you want, and things like that. So this is just something to be aware of. It really, to configure it, you just add transforms. So you can kind of see on the top there that this example has 2 transforms, and you have to specify the Java class that implements the transformation. And then you can also add additional configuration if your specific transform requires a configuration.
I'm going to just kind of show a few overviews of what we commonly see customers do with this technology. So in this one, this is ingesting data through a data producer going through cluster, using Kafka Connect to come into Snowflake, using streaming. And in this case, it's landed inside this raw table. And this raw table is then getting conformed by using a dynamic table. So there's like some reshaping being done in here. So it's a fairly small transformer that's happening inside of Snowflake here using dynamic tables. Or they could have also, or you could have also used using our streams or tasks to then create this conformed table. We saw this really commonly in Snowpipe before streaming. And really this is because the data probably wasn't landing exactly the way you want end users to query it. There had to be some reshaping or something happening in here before it can be queried by your data consumers downstream. The consequence of this is dynamic tables and tasks both have lag that introduces latency in this design. So in this design, often this is minute-ish type delays between when data is landing. We just optimized all this upstream pipeline to happen in seconds, and then there's these tasks in here that take minutes before it lands. So what we're seeing customers that are really concerned with latency doing, they're shifting to this pattern, which is using the things like those SMTs and other patterns to make sure the data is landing conformed. So it's no longer waiting on an async task to then transfer that so it can be different. It's landing exactly the way that they want the consumers to query it. For the most part, that means that now data as it lands is immediately queryable by customers or by your end users. And then also there may be some other materializations happening. That doesn't mean this solves every problem. This solves the part that actually was the most latency sensitive. So if someone wants to come to some dashboard that shows the last 10, sure, the last 10 should land on the conformed table. That doesn't mean you don't have other aggregations happening in the background to power other graphs. And it probably will be a combination of those. But this kind of now balances both latency for those queries that do need the high-speed data, and then also you can kind of help performance by still creating materializations asynchronously for the things that are less latency sensitive. We wanted to talk a little bit about optimizing for performance. Adding cluster keys, I'd highly suggest you do this for every table you're doing streaming in. We showed in the diagram earlier we're doing those file migrations. The file migration service and auto clustering service are almost the same cost. So if you enable auto clustering, it replaces file migration. So you can get clustering benefits on these tables for almost free. So almost every customer I work with, I'm like, there has to be some set of cluster keys that helps out your downstream queries. We should find that and apply that to your table because you're getting it really, really affordably here. Avoid small chunk sizes. So we did talk about all of those settings for like these flush rates. You can see inside of our instrumentation these sizes of these BDECs that are getting uploaded. If you have too small files in here, you're still going to see some performance impact for those live queries that are hitting those files. So still try to avoid those small chunks getting uploaded to Snowflake. So we haven't completely removed get to well-sized files. We've just made it a bit easier for the system. And small files do work. It's mostly an optimization, trying to get to the best performance. For query pruning on BDEC, we do need those fields to be top-level columns. So that's another reason to use those SMTs. If you need to reshape data that's in Kafka, it's important to get anything you want to prune on to get up to those top-level columns. Keith is going to go on to the next section.
All right, so let's talk a little bit more about monitoring and error handling. So it's kind of a big topic here. Not going to get into it in tremendous depth. So Kafka, Kafka Connect, and even the Snowpipe Streaming Java SDK have a lot of metrics. Those are captured typically in JMX. And so depending on your Kafka infrastructure, depending on your specific setup, this is something where you want to figure out how to take those metrics and export them into an observability platform. It could be something like CloudWatch. It could be something like Prometheus. It could be something like Splunk or Datadog or something. But the goal is to capture all those metrics out of the different pieces of infrastructure so that you can monitor what's happening. I'll talk on a later slide about some of the different metrics that are good to look at specifically. But one other thing I want to call out from just like a general monitoring perspective is that Kafka Connect also has a REST API. And so this is great for deploying connectors and managing the life cycle of connectors. In this case, we're using the Snowflake connector on Kafka Connect. But it's also helpful for monitoring and for remediation. So you can check on the status of the sync. You can check on the status of specific tasks. You can see when things failed via API calls as well. And then you can programmatically trigger restarts and things like that. So there are, this is often part of a comprehensive monitoring strategy. And then once you have all these different metrics, it's good to create alerts. There are certain things that you really want to know about when they're happening, like things like consumer lag increasing, or the sync is down and failed, or things like that. We'll talk more about some of the specific ones. But there are lots of good open source dashboards. Like Grafana has some good ones available where you can see good Kafka monitoring dashboards and specifically look at some of the metrics and how they're typically queried and analyzed. And just one thing here, I've seen a lot of customers that are kind of new to Kafka, and they try to do really comprehensive, complex monitoring early in the project and kind of get hung up. So if you are new, I always recommend kind of starting simple, getting some of the key metrics in place. And then as you do more development and testing and scaling and you find any particular gaps in your monitoring strategy, you can always add more. There's just a huge amount of data that you can tap into if you want to. Now, the other aspect here is error handling. And so there's really two things that I would recommend if you want to avoid data loss. Like there might be some use cases where you don't really care about data loss. Like for example, it's like some kind of an IoT exhaust, and if you lose a couple messages, it's okay. But for the most part, you don't want data loss. And so one of the settings would be error tolerance is stop. And that will basically, when there's a bad record, the specific task that is consuming it and running it to Snowflake will just stop. And so this is a way where you can get alerted, you could figure out why there's a problem, you could remediate it and then turn it back on. That's probably not what you want though. You probably want to configure a dead letter queue. And this is something where you'd want to make a dead letter queue for each specific Snowflake connector if you have more than one. That requires its own topic. And then you can turn on something called context headers when you configure your dead letter queue, which adds a lot of additional metadata, which shows you like why it failed. It'll give you a stack trace. It'll give you detailed error messages. And then so you can actually, there's different things that you could do with the data in the DLQ, but you can decide kind of how you want to action on the data, based on some of that additional context header metadata. And this is also from a monitoring perspective, look at your DLQ topics. Like if you start seeing things in a DLQ, that's bad. And you probably don't want to see anything in there, to be honest. And so here's some of the metrics. There is quite a bit. I've tried to bold the two that I think are the most important. So one here is consumer lag. And so that's basically, is the Kafka connector keeping up with the producers, and is there a gap, which would indicate that maybe you have too much data coming into a particular partition. This could be if you see consumer lag. This could either indicate that the Kafka connector is down or they're just overloading a single partition. On the Kafka Connect side, really just looking at the health of the connector and the tasks, making sure that they're all running. And then if you really want to get more detailed, with the Snowpipe Streaming Java SDK, you can turn on additional GMX reporting, and you can get metrics from the actual upload of data to Snowflake. You can get things like the throughput, the records per second, chunk size, and also you can compare the offsets coming off the Kafka topics to the offsets that are committed in Snowflake and see if there's a gap there. It's almost like a different type of lag. So there's a lot in, really this is like hundreds and hundreds of different metrics, which is why I say kind of, begin with something simple that works and then add more detail in. Before we get into this.
You want to flip to the demo?
Yeah, let's go back to the demo. We'll see
if it died in the middle.
Yeah, hopefully not. All right, so cool, we're back up here. So I'm going to run now two queries. So one is going to show the total amount of data that we've ingested as we're talking. And we're going to see both a compressed and an uncompressed size here. So let's see how it looks. All right. Okay. So we have loaded, it looks like, that's a lot of records. So that is 15.3 billion messages. Looks like 8 terabytes uncompressed and something like 1.5 terabytes compressed. So it looks like it is working pretty well. So let's see, what does that actually mean? What is that from a throughput perspective? So I have one more query here, which is kind of a simple methodology. It's basically just using a timestamp in the messages itself, getting the duration by comparing the min and max of that timestamp. And then one other thing that I'll call it specifically is kind of going from uncompressed to compressed. I do have like a hard-coded compression right here. So what I did was I actually went into the logs of the Kafka connector, and you can see every chunk that's uploaded to Snowflake. You can see what the uncompressed bytes are, what the compressed bytes are. And so you can kind of spot check and see what compression rate you're getting. This is going to vary quite a bit depending on your particular data model. So let me run this other query and let's see how we're doing from a throughput perspective. So, and this is a metadata-based query. There's just lots of files and lots of data that got loaded very quickly. And so it looks like we're getting, let's see here, in 30 minutes of talking, we've been getting 8.7 million records per second on average. And we're getting about 4.7 gigs per second. And then compressed, we're getting 879 megs per second compressed, uploaded into Snowflake. And that's based on 400 partitions. So we are getting over that 1 meg per second that we talked about. But in this case, part of the reason why that's happening is because this is a kind of a smaller message size. Like it's something like maybe 15 columns or so. And it's compressing at like about a 5.39 compression rate. For larger messages, you'll probably see higher compression rates than that, particularly ones with like lots of semi-structured data. And yeah, so that's a demo.
Thanks. Hopefully that was pretty cool. It's a lot of data. Yeah. A lot of customers want to see this because they come to us and they say, I have a lot of data, and we can pretty much push as much as we want through. We literally hit our Amazon limits on our account, so we couldn't go any higher than that without a request. So I want to talk a little bit about what's coming soon. We are working on a pull for connector for Kafka. So a lot of the infrastructure we had to spin up were all those connect nodes. That was a lot of resources, that was a lot of configuration. Snowflake knows this is hard, so we're working on a pull connector that'll be native to our platform. And this will basically just remove all of this concern from your side. So we'll be running all the connect infrastructure on our side, what looks like connect infrastructure on our side that's pulling the data out of your brokers. The one thing to think through on this a little bit is that we will have to pull directly from your brokers. So right now, those must be publicly accessible. We're working on some technologies to make that, some alternatives to that. But right now, if you were to sign up, this is in private preview. You could talk to your account team to get access, but we need public brokers there. This does still maintain exactly one semantic, so it works very, very similar. But it completely removes all the Kafka connects. So you don't have to configure it, you don't have to manage it, you don't have to scale it. All of those things go completely away. It'll be billed in compute seconds, so completely serverless to you. You don't have to manage the infrastructure. You'll just be billed on what we need to run to be able to keep it up to date. And it's also going to be similar low latency with what we were doing today with streaming. The next thing that's currently in development, this will be private preview very soon, is a row set API. And what the row set API is a set of endpoints that we're going to be running that allows your client, as long as it has HTTPS access to Snowflake and can authenticate, it can send single messages to us. And then we're running infrastructure for you that then batches and then writes that into Snowflake. So we've completely eliminated all of Kafka Connect, and your clients can send single messages directly into a Snowflake table. So this removes Kafka and Kafka Connect from your infrastructure if you just want the data in Snowflake. And we're seeing a lot of cases that customers are needing to do this message bus. They need to get messages into Snowflake, but often they aren't using Kafka yet. It just removes all of the overhead of managing that infrastructure and has all the other benefits that we talked to earlier. So very low latency, very quick to get data into Snowflake, and also exact once semantics, which is really nice.
The other thing that I would want to call here is that Snowpipe streaming right now, prior to this, requires the Java SDK. And so this is going to be a REST API. And so you could produce messages to this from Python or from Node or whatever other language or platform you want to stream data from. And so that's something also to keep in mind. It kind of just creates new possibilities.
Yeah, it's extremely lightweight client there. That's all me and Keith have. Thanks for coming today, guys.